Chapter 6 is about the integration. Integration with applications. All right, what we did in the past, we have done a lot of derivative or differentiation. So I'm going to summarize real quick about the overall picture of calculus. The calculus has two branches. The first branch is called differentiation. That's what we did. And the second branch is called integration. If you think about the big picture of each one of them, differentiation is based on the difference quotient or the slope formula, like y2 minus y1 over x2 minus x1, and put the limit as x1 approaches x2. That comes up to be the derivative. So the differentiation is about the difference and the quotient. Okay, kind of make it small and small, different, and then the quotient involved, where the integration is about the product and the sum. Okay, so differentiation kind of look at the rate of change of the small quantity. Integration going to be the product of the sum. So going to be two totally like different groups of the concept. Integration. Now what we're going to start with, another name of the integration is called the antiderivative. The term derivative, we have done many times. And with the prefix, the anti, that means the opposite operation. Okay, for example, if you have the problem y equals f of x as x squared, okay, and then you find the derivative f prime, this one called derivative of f of x. So f prime is, I'm sure you guys know how to find the derivative of x squared, right? Which is 2x. So this is the way that we did in the past. Find the derivative of the function. For the antiderivative, we're gonna do it backwards. Okay, backwards. So if you make this as the notation, I put the here as the function. Let's use the function as a function g. If gx is 2x, so we do backwards. Okay, when we do backwards, start with the gx is 2x. On the other side here, the capital Gx is x squared. It is called the antiderivative of the lowercase g. So you do backwards instead of going forward like last time. So the formula going to be opposite. Opposite, it doesn't mean negative sign. It's like if you start with the bring the power down to find the product. I mean, bring the power down as a coefficient. So instead of bringing the power down, you're going to make the power at the denominator, which we're going to go over the rules in a little bit. Okay. So just to give you a brief idea of the antiderivative, what does it mean? So it means you start with a term that, which is basically the result from finding the derivative of something, but you're going to use this to find the original function and ask yourself the question that what function that you use that the derivative is provided as 2x, and the answer is the function that you use to begin with should be x squared, because the derivative of x squared is 2x. So in this case, we call x squared as the antiderivative of 2x, where 2x is the derivative of the x squared. So kind of you go backward, forward, okay? And then for the definition of the antiderivative that you see on the notes, page 1, the uppercase f and the lowercase f, they are two functions. You find the derivative of the uppercase f equals the lowercase f, is kind of kind of confusing, right? So we call the uppercase f an antiderivative of the function f. So in this case, so the uppercase f is x squared and the lowercase f is 2x. The relationship of these two as the uppercase prime is the lowercase. That's what it means. So we call this the uppercase as the antiderivative. Okay. And don't worry too much about the notation. I just want you to see the concept of getting the backward operation. And the other one, the other concept of this is if you let me go to different color. So the two functions, the function g and the function f, the two uppercase letter f and g, if both are the antiderivative of the same function, that means f of x prime also the same function f and the uppercase g prime also the same function x, f of x. So that means we can write one in terms of the other. So that means the uppercase f could be in the form of the uppercase g plus the constant c. For example, similar to the one that we use and easy to look at it. If f of x equals x squared and the uppercase g is x squared plus 5, think about what is the derivative of the uppercase f. You get the same, 2x. And for the uppercase g, you find the derivative, you get 2x as well. You see if the derivative of both uppercase f and uppercase g gives the same expression, it is not necessary that f and g are the same function, but they can be related as one added by the constant term because the derivative of the constant is 0. Okay, we're gonna use this relationship to find the most antiderivative. It's called, or the term like all antiderivative. Okay, now let's see example. Hopefully you can see the better picture of it. For the first one, we're gonna show that the uppercase function f is x to the third plus x to the second plus 50. And the function g, the uppercase g, is x to the third plus x squared minus 80. We're gonna show that both of them, both uppercase f and uppercase g are antiderivative of f of x equals 3x squared plus 2x. When you have to show, that means you're gonna prove that it's correct. Show that these are antiderivative. And the concept of the antiderivative means you are going to show that the f prime equals the function f and the g prime also the same as the function f. And from what we have, this is 3x squared, right? 2x. So to show, we just work on finding the derivative of the function f term by terms. And same as the function g or the capital G, find the derivative of it. And this is the polynomial function, which is not too bad to find it. So for the f prime of the x, we're gonna get 3x squared plus 2x and then plus 0 because the derivative of the constant gonna be 0. Similar for the g prime, we have 3x squared plus 2x plus 0. And that's show us the derivative of both capital F and capital G function the same as the function f or the lowercase f in the form of 3x squared plus 2x. And then this one is enough to show that both uppercase f and the uppercase g are antiderivative of the lowercase f. And when you look back at the f and g functions, okay, they have the common two terms in the x term, but the difference would be like 50 and negative 80. And the other way you can see this as the f of x is in some form of the gx plus the constant c. So if you have this relationship, that means both f prime and g prime will give you the same expression. And we can say that both f prime and g prime will give you the same function, or we say the f and g are antiderivative of the same function. Okay, the first example here is just a concept problem to make sure that you get the concept or understand the concept of the antiderivative and how you can work it out.